Alright, ladies and gentlemen, so I wanted to make a quick video today to introduce you to this lab that we're going to complete, which is using a digital tool from PHET, which is a different program that has digital tools. We'll come to a couple other ones this year, but our first one is going to be this idea of forces and net forces. So the first thing I'm going to do, when you open up this assignment, you'll see that little paragraph at the top. I'm going to read that to you. Forces are what scientists call the pushing and pulling of objects. In a tug-of-war, people are using forces in opposite directions. In this activity, you will use a simulation to explore the results of using differing amounts of forces in a tug-of-war over a cart of candy. You will be able to see the amount and direction of the forces to calculate the net force, or the sum of the forces. The net force will reveal the direction and speed of the motion. For this activity, you will be using a digital lab tool. This tool works well on Chromebooks and laptops, but may not work as well on a phone or a small tablet. So if you have a full-size piece of technology, today would be the day to use that. So the first thing you're going to do when you open this lab is let's scroll and find the first question. This lab is broken into 3 parts. The first question here asks us to look at the picture of people pulling on a cart of candy. For each picture, which way do you predict the cart will move? Explain your predictions. So when I see these carts here, we're going to think about the first cart is cart A, then we have B, C, D, E. And I want to think about each cart, and I'm going to write a sentence to explain what I think is going to happen. So for cart A, I expect, well, if I look at this one here, I see a big person, and I know big people are strong, and I see a small person. If these two are pulling on this cart of candy, I think that the big person is going to win, my blue person on the left here. So my sentence might be something like, for cart A, I expect it to move to the left because there's a bigger person over there. Then I'm going to do the same process for each of the other 4 carts. For cart B, I expect it to go whichever direction and explain it. C, D, and E do the same thing. Your options are right, left, or no motion if you think the cart would not move. Once you've made your predictions for each of these carts and typed in your responses in the box, you're going to scroll down and we're going to actually try it out. We're going to open up this simulation. When you click on the tool, let me jump to the next tab. When you click on the tool, it'll open up this tool here where we see forces in motion, and we're going to use this net forces. There are other tools built in, but all of our lab today will focus on this idea of net forces. And we're going to build each situation. So for that first one, I see a big blue person on the second knot, big blue person on the second knot, and I see a small red person on the second knot on the other side. I'll hit go and see what happens. So I predicted that it would move to the left. When I hit go, oh man, they're pulling. And I was right. The cart is moving to the left and the blue won. When I restart this here, now I'm going to set up the next situation, run it and check. Did it match what I predicted? So for your explanation here, it can be something like, I was correct for carts A, B, and D. For cart E, explain what you did wrong. For cart C, explain what you did wrong. So do your best running through these ones here. These ones we're working on it without any numbers. This is just looking at the visual representation of force. When you hit next, now you're going to come up with trials where you need to describe them using numbers. So you may not use this exact example that I'm going to run through with you on this video and in the words here. Your simulation is that same one that you had open, so you don't need to change anything. One trial that we might do is a small blue and a medium blue on the left. So let's drop those in there. A small blue and a medium blue on the left. And I need to have these options chosen. My values, my speed, my sum of forces. Well, when I added my little guy, that was a sum we added 50 newtons of force to the left. So my little guy, small blue, was 50 newtons of force. My medium blue, well, if I had just medium blue adds 100 newtons of force. So medium blue was 100, and that gives me a sum or a net of 150 newtons to the left. On the other side of the cart, I'm going to have 2 small red people. Each small red person adds 50 newtons of force. So I see small red 50 newton, small red 50 newton, which gives me an overall net force of 100 newtons to the right. When I hit go, I notice that my cart is moving to the left. I see that my net force is pointing to the left with 50 newtons. Again, blue wins. The cart moves to the left with a net force of 50 newtons. So now your job is to come up with different situations. Plug your red and blue guys in, come up with different ways, and figure out how your cart moves. Or how it doesn't move. See if you can come up with a situation where you're using people and the cart is not moving. Type it out with sentences to describe, just like I did in this example here. And you need to have 3 different types, 3 different situations. Then when you hit next, you're going to analyze it. These analysis questions must be answered with complete sentences in order to receive full credit. You're going to think about things like, does it matter if they're red and blue? Explain with the complete sentence, give me details, give me evidence from your experiment. Does a large person always win? Well, I'm giving you a hint here, they don't. See if you can come up with evidence to show me that a large person will not always win. Can you make the cart stay still? Well, how can you make that happen? Give me 2 different ways. And if you want, you can go back to your simulation and come up with 2 different ways. You can practice it, drag and drop your people, hit go, see if you can come up with 2 ways to make the cart not move. Does it matter what part of the rope a person holds? So does it matter if my guy is on the 1st knot, the 3rd knot, the 4th knot? See if that affects the force and explain it. The last question, you need to give me at least 3 to 5 sentences telling me everything you've learned about forces and net forces from this activity. Your summary should include a definition of the term force and of the term net force or total force. When you're done with all 3 parts of this activity, you can hit submit and you are done with the lab for today. Thanks, guys.